Lesson 2.1, Quadratic Functions and Models. By the end of the lesson, you should be able to analyze graphs of quadratic functions, write quadratics in vertex form, use the results to sketch the graphs, find minimum and maximum values, and apply it in real-life applications. Okay, the definition of polynomial function. So this formula looks pretty intimidating, where they're telling you it's a non-negative integer. You have a sub n minus 1, and a sub n minus a sub 2, a sub 1, a sub 0, and it looks really complicated. Basically, what this is just telling you is you have some type of degree where it is counting down. So like x to the 5th plus x to the 4th plus maybe x cubed, and it's just going all the way down to x to the 0. Okay, and in this, we are really focusing on the second degree, the x squared, which is quadratic functions. So here we go. All of these are quadratic functions. How do I know? I look at the highest degree. There's a 2 here, there's a squared, here's a squared, here's a squared, and remember x times x will give you x squared, and that's how we know these are all quadratic functions, because the highest degree is 2. Okay, so now we have some graphs of quadratic functions. Notice this is the same thing we did with a, b, h, and k as we did in absolute value and linear functions. So we start with our parent function, and our parent function is y equals x squared. If you forget what that function looks like, you can always do your t-chart, your xy t-chart. You could pick numbers, so any number you want. I'm just going to pick -2, -1, 0, 1, and 2. And when I plug it in here, I get -2 quantity squared is 4, -1 quantity squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. If I were to plot those points, I would get, so -2, 4 would be somewhere up here, -1, 1, 0, 0, 1, 1, and then 2, 4 would be somewhere up here. So you could see this gray graph represents the parent function. Okay, and this negative, remember the negative just is an x-axis reflection, and then +1 moves the graph up 1. So if this graph was reflected, it would be going downward, and then the graph is moved up 1. We see we have x plus 2 quantity squared minus 3. This is always the opposite, the x minus h. So my graph is moving left 2 and down 3. So here the vertex, left 2, down 3. So in order to look at that, we need to know the vertex form. So the vertex form of a parabola looks very similar to the absolute value form, right? You have the a times the x minus h quantity squared. So in absolute value, you saw the absolute value right here instead of parentheses. These were absolute value. Okay, and there was no squared. So it looks pretty much the same. Then you have your plus k. Your hk is the vertex. The axis of symmetry is x equals h. When a is positive, the parabola has a minimum and opens upward. So this is the same thing where I used to draw the happy face. When a is positive, my graph is going up, and therefore it has a minimum. Okay, when a is negative, my graph is going down, and this is the top. It has a maximum.